Today we're going to do information from graphs. First thing at the top of your paper, it says maximum and minimum. What are some other words that mean maximum? Highest is maximum, most. Please write these down. Highest and most are other words that mean maximum. What's one more?
Lowest and least.
Maximum. Starts with a G. Greatest. All right, write those three down. Those are the ones that most commonly you'll see. All right, now for minimum. Starts with an S. Smallest. Okay, so if you see one of those words, like if you see the word maximum, it means what is the highest value. Or if you see when is it the most, that's the same thing as asking for its maximum. Okay, so all these words mean the same thing. All right, problem number 1 says, say is the goalie on a soccer team. A kick he made is modeled by the graph below. It shows the height of a ball over a period of 2 seconds. What was the maximum height in feet that the ball reached? All right, what should I circle first before I even answer the question? What should I circle? Thank you. Maximum height. Maximum is going to be the highest point, and so what's the highest height? 16. What if the question said, when did the ball reach the highest point? 1 second. Good. Okay? All right. Number 2, suppose that the equation v equals 20.8x squared minus 458.3x plus 3,500 represents the value of a car from 1964 to 2002. What year did the car have the least value? Okay, so what word should I circle? Least, thank you. Now this one did not give me a picture or a graph to look at. It gave me an equation, okay? What can I do with that equation to figure out when it's going to have the least value? I can't solve that. That's a pretty crazy equation. What? I can put it in my y equals. So everybody do that now. So hit your y equals button on your calculator. All right, so I'm going to type in 20.8x squared minus 458.3x plus 3,500. Now I did, when I was typing this, I did forget to put, they had in the book x equals 0 in 1964. Okay, so anyways, basically, I forgot this, but this is important. It tells you where to start. Where do you start looking with the x at? At 0. Okay, so look. So once we type it in, the y equals, once we type it in, we're going to go to second graph, but your calculator may not be at 0. If yours is not at 0, you need to do second window and tell it to start at 0. Second window. Look, second window. Did you put 0 in? Okay, then go back to second graph. All right, you there? Okay, other questions? Okay, we're looking for the least value, and if you notice, 3,500 is my starting value, which is exactly what the calculator gives me. And the car is going down in value. The car is going down in value. All right, where is it the least value? When does it have the least value? At 11, good. At 11, that is the lowest number that you see, 975.5. That's the lowest number at 11 years. Okay, let's write that on our paper, 11 years. All right, is 11 an answer choice? No. Okay, what year did it start in? All right, so we have to do 1964 plus 11. 1964 plus 11. What do you get there? 1975. Okay. All right, the next one, number 3. Suppose that the equation v equals negative 10.4x squared plus 378.5x plus 10,000 represents the total value of an investment X years after 1985. In what year does the investment have the greatest value? Jeremy, what word do I want you to circle? Very good. The greatest value. Stephen A., how are we going to answer this? What are we going to have to do first? Very good. We're going to have to put it in our y equals. Guys, don't forget about the negative in front on this one. It starts off with a negative. If you forget that negative, it'll mess up your whole answer. So negative 10.4x squared plus 378.5x plus 10,000. Please quit talking. Plus 10,000. And I'm going to go to second graph. And I'm going to go back to 0 so that I'm not just kind of jumping all over the place. I like to start at 0 so that I can be methodical. All right. If you notice, this one, your investment goes up in value. So it keeps going up. It's getting bigger. It's at 11,000, 12,000, 13,000. Up. It's going back down. So let me find when it was the greatest. When it was the greatest. All right, good. 13,443 is the biggest number. So that's 18 years. Elijah, is 18 years an answer choice? What do I have to do with that? To what? What year did it start in? 1985. LeVar, what do you get for your answer? Hit second, quit.
Oh, thank you.
Number 4, a company's expenses in millions of dollars, D, can be modeled by the following quadratic equation, where T is the time in years after the company started. What was the company's minimum expense? Jack, something I want you to circle. Thank you. Anybody else know something that's important I should circle on this one? Millions of dollars. That's going to come into play. Okay? Brandon, what do I need to do to find the minimum expense? Good. Put it in your y equals 2x squared minus 8x plus 9. All right, once again, I'm going to go back to 0. I'm going to go back to 0 to start looking. All right, to start looking. Riley M., what is its minimum? What's the smallest number that it is? What's the smallest number you see over there? 1. Okay. So its minimum expense is 1 million. What does the 2 stand for? Good. So it's 2 years. They've made $1 million. All right. So they've put it into millions. The calculator just had a 1, but it's 1 million. Okay. Number 5, a firework is launched from a cliff overlooking the ocean. The elevation of the firework, I think that should say shell, in feet above sea level t seconds after launch is given by the expression negative 16t squared plus 157t plus 63. What is the maximum height of the firework? Stephen R., what do I want you to circle? Good. Maximum height. Faith, how are we going to answer this question? What are we going to have to do? Put it in our y equals. All right, Shakir, what are you getting for the maximum height? Good. 448 is the largest number that you see, because then it starts going back down. Okay. And the reason it starts going back down is because what happens in real life? They shoot a firework from the ground, right? It goes up, it bursts, and then it falls back down. Okay. Which leads us, I think, to the next thing. All right, so on your paper it says the height formula for an object in the air. So this is a science formula. You might see it if you take physics or physical science at South. If you will write this down, I'll explain what it means in a minute. I know it's really weird looking. I'll explain it in a minute. If you'll just write it down, F of t equals negative 16t squared plus v sub 0 t plus s sub 0. I'll explain what those mean in a minute. All right, so like I said, this is a science formula that anytime you throw something in the air, a football, if you launch a firework, if you throw a penny off the Empire State Building, this formula tells you how high it will be after a certain time, okay? This right here is gravity. It is the formula for gravity. Why is it negative? Gravity makes it go down. Good. So that part is gravity, so if you'll label that. This right here is your starting velocity. So that 0 right there is because the starting value always goes with 0. That's why they use that notation. So that's your starting velocity. What's another word for velocity? Speed. Good. And the last thing is your starting height. That is your starting height. So again, they're just using this zeros to tell you that it's the starting value, because starting value always goes with 0. Okay, so let's actually use this in a problem. It'll make a little more sense. Number 6 says, a punter punts a football with an initial velocity of 48 feet per second when he is holding it 4 feet above the ground. How far down the field will the football be after 2 seconds? Okay, did they give you an equation in this one? So you have to make one. So, write y equals. So this is number 6. What's happening in this problem? What are they doing? Throwing a football. Will gravity act on that football? Yes, so we need to put gravity first. Negative 16. I'm going to put x squared. You can put t or x. It doesn't matter. Negative 16x squared. Then we need to put the starting velocity. What was the starting velocity of the football? 48. So we put plus 48. And we have to put an x beside it because it's going 48 feet per second. That's why it gets an x beside of it. Plus, he held the football out in front of him. He held it out 4 feet, and then he kicked it. So he held it off the ground 4 feet. So we got to put plus 4 for its starting height. All right. The last thing I need you to do, so stop with your calculator for a minute. Stop, stop, stop. Look up here for another quick second. Please write this down. I'm not going to make you do it every time, but I do want it on your notes for at least one problem. You know how the calculator does an X and Y table? Okay. What is X pretty much all the time, like in a word, in one word? What does X stand for? Time. Good. So let's write that down. X is the time. In this particular problem, what is Y going to be? What? Yes, it's going to be feet. It's also going to be height. All right, but we'll do feet. Feet, height, whatever. Okay. So you need to make sure you understand which column is what. Okay, now let's put it in our y equals, and we'll talk about it a little bit more. So now let's put it in our y equals. Okay, so the question is asking. So there's no point in you just la 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 going through the motions if you don't understand it. So I want to make sure everybody's on board. What is the question actually asking? After 2 seconds. After 2 seconds. So is 2 going to be in the X column or the Y column? Seconds is time. So 2, we're looking for 2 over here on the X side. So I'm going to go to second graph, and I'm going to 2 on the X because this is time. So this is 2 seconds is what that means. 2 seconds. How high is it after 2 seconds? 36 feet. All right, number 7. A punter can kick a football from the ground with an initial velocity of 48 feet per second. When will it reach 20 feet? All right, so we need to write another y equals. We need to write another y equals. Stephen A., what's the first thing that should go in our y equals? Good, negative 16x squared. Hallie, what goes next? So how do we write that? Good, 48x. Brandon, what is the starting height in this particular problem? Where does the football start from? It starts from the ground. So what's the starting height? 0. So you don't have to put it, but the starting height is 0 on that one. Okay? All right, Faith, what's the question asking on this one? Good. 20 feet. 20 feet. Madison, will 20 feet be in the X side or the Y side? Is feet? It's Y. All right, so we're looking for 20 on the Y side. All right, so I'm going to go back to my Y equals. Let me delete the 4 out. All right, do you see 20 on the Y side? No. So let's use our answer choices to help us. What does answer choice A say? 0.3. So go to second window. Everybody do this with me, please. Go to second window and type in 0.3. And then go to second table. Is it 20 feet there? Okay, what does answer choice B say? So second window, type in 0.5. Is it 20 feet there? Yes. All right, number 8. The formula is used. Oops, sorry, I've got that one not typed right. The formula h of t equals negative 9.8 t squared plus 3t plus 12 is used to find the height in feet. Find the height of a swimmer after 0.3 seconds. Shakira, what do you think I need to do first? Good. Put it in y equals. Do it with me, please. Type it in your y equals. The reason this one's 9.8 is because it's meters per second instead of feet per second. All right, Elijah, what's the question asking on this one? Seconds, right? So do I want 0.3 on the x side or the y side? The x side, because x is what? Time. Okay, so I need 0.3 on the x side. Samaria, how can I get 0.3 over here? What can I do in my calculator? Good. Second window, type in 0.3. And Chase, what's the answer? B, 12. Okay. All right, number 9. LeVar, read that one for us, please. Okay, very good. Thank you. All right, guys, what is this one asking for? How high is the cliff? How high is the cliff? You've got to read carefully on this one. What's happening in this problem? I'm shooting a firework. Tell me more about that. I'm shooting a firework off of a cliff. Does it ask how high the firework will go? No. It's asking how high what is the cliff? How high is the cliff? What does the cliff have? What significance is that in this problem? Tell me about the cliff. It's where I'm shooting the firework off of. All right, so you're on mute for a minute. Got to get other people. What, Brandon? It's your starting value. So how high is the cliff? What? 63. You don't even have to put that one in your calculator. The cliff is 63. It's your starting point. The cliff is where you're launching the firework from. Okay. All right. Hits the ground or the water. So let's say I'm throwing this marker and it hits the ground. How high is it when it hits the ground? What? 0. So we're going to put the height equals 0 right here. Height equals 0. Height equals 0. All right, number 10. While standing on a cliff 30 feet from the lake, Serena threw a rock with an initial velocity of 20 feet per second. How many seconds does it take the rock to hit the water? All right, circle, hit the water, please. Circle, circle, circle. Hit the water. We're going to put H equals 0 whenever we see that. When it hits the water, the height has to be 0. Okay? Have they given us an equation? No, we got to make one. Let me call on somebody. Zach, you're up. Help me with a y equals. What can I write? All right, so start with gravity. What's the gravity part? So negative 16x squared. Then keep going. Plus 20x plus 30. So 20 is your velocity, and 30 is the starting height. 30 is the starting height. Okay? All right, Jeremy, where am I going to have to put that equation? Where does this go in my calculator? Yes, Jack?
So, like, in real life, how would someone even, like, measure that? Because, like, when you throw something, your hand goes up, you know. So, like, I mean, I guess.
So we'll type this one in. Negative 16x squared plus 20x plus 30. All right, Riley M., what is the question asking on this one? Good, so what are we looking for? What number? 0, okay? I don't see 0 anywhere, do y'all? No, we're looking for it over here. Remember, this is height. Over here, we're looking for 0. So let's test our answer choices. Let's test A first. 1 point. Well, hold on. Before we do that, let's be smart about it. See how, what are we doing? What are we doing in this problem? Throwing a rock. So the rock is at 30 feet. It goes up to 34, and then it's falling back down to 6. Can the rock be negative? So somewhere it hits the ground between 2 and 3. Do y'all agree with that? All right, so what answer choices are between 2 and 3? C and D. So we can just test those two. All right, so I'm going to go to second window, and I'm going to type in 2.02. 2.02. What is it at there? All right, and then what does D say? All right, let's try that one. 2.13. Yeah, which one's better? 2.13 is when it hits the ground. Okay. Number 11. Jack, read that one for us.
Of it drops his MacBook from 150 feet cliff. The height of the book after t seconds is given by the formula h equals negative 16t squared plus 150. About how many seconds will it take the book to hit the ground?
Good. Stephen R., what should we circle? All right, so that's important. Zach, what else is something we should circle? Hit the ground. Faith, what do we know when it hits the ground? What's the height going to be? 0. Height's going to be 0. All right, Stephen A., where do we go from there? Good. Type it in your y equals. I should see people typing. All right, I'm going to start it back at 0. Right now I got some crazy decimals, so I'm going to start it back at 0. All right, LeVar, when it says hit the ground, I'm looking for the height to be 0. Am I looking for 0 in the X or the Y, LeVar? For height. Is height X or Y? Y. So I'm looking for 0 over here. I don't see 0, but I know it's going to be between what? When is it going to hit the ground? Between what? Between 3 and 4. Okay? Do y'all have multiple choice on this one? No. Okay, so let's just write between 3 and 4. It'll be multiple choice on the test. What you could do, I don't want to confuse anybody, but some of y'all are going to want to go to honors, so let me show you this in case you go to honors next year. If you go to second window, so that tells it where to start. This right here, this triangle, tells it what to go by. So like right now, it's going by ones. 1, 2, 3, 4, whatever. But I could tell it to go by 0.1 so that I can have a more accurate picture. So second graph, And I'm trying to find 0 over here. Let me go ahead and go to 3. Tell it to start at 3 because I know it's going to be between 3 and 4. All right, so I'm starting at 3. I'm going by 0.1s. It still doesn't give me, well, okay, it does help me a little bit be a little more accurate. Is it going to hit the ground closer to 3 or closer to 4? When is it actually hitting the ground? Closer to 3. Pretty much 3 is when it's hitting the ground. Because at 3.1, it's negative. So it's hitting the ground pretty close to 3 seconds. Like 3.0 something. Yeah. Okay. All right. All right. Last one. Putting it all together. La la la. Riley M., read this one for us.
You are throwing a baseball with your brother in the backyard. Put the ball in close to the baseball if the ball follows the path of the quadratic function f of t equals 6 t squared plus 43 t.
Good. And I should have a T up here. All right. A says, Madison, read A for us. Good. Brandon, what does it mean by when I release it? Good. The starting value. Good, Brandon. So that one's asking for the starting value. Riley K., what is the starting value? 6. Okay. B says, how hard are you throwing the baseball? Hallie, what's another way to say that? How hard are you throwing it? What is its what is its velocity? What is its speed? Which one of these is the velocity, Hallie? The 42. So you're throwing it 42 feet per second is how fast you're throwing the baseball. C says, how long is the baseball in the air before it hits the ground? Jack, what's important for that one?
Y equals.
You're going to have to put it in your Y equals. What does it mean by hits the ground, Jack?
Oh, like when it hits 0.
Good. When the height is 0. Thank you. All right. So last one to put in your Y equals, please. So everybody do this. So Mary, when is it going to hit the ground? Between what 2 seconds? 2 and 3? Let's just say 2.5. So that way we don't have to write as much. 2.5 seconds. Okay. D, what is the max height of the baseball? Elijah, what should I circle for this one? For D. No, right here. What should I circle in this question? Max height. All right, Chase, according to this, what is the max height? Did you go, is yours in 0.1s? Okay. Let me look at 0.1s. So let's see, it goes up 30, 32. Yep, 33 is the, well, actually 33.56, right? If you're really technical. Okay, I'll accept 32 or 33 on this one, but if you're going by 0.1s, you can see a little more accurate. All right, E says, what is the height of the ball after it's been in the air for 2 seconds? Shakira, what should I circle on this one? Height after 2 seconds. Brandon, where do I look in the 2 for? The X or the Y? The X. So I'm going to go to second window, 2. Elijah, what do you get for your answer for that one? 26. And the last one. Chase, read that one. Good. LeVar, what should I circle for this one? And G, what should I circle? And what else? 20 feet. LeVar, will 20 feet be in the X or the Y? Height is Y. Guys, you definitely want to go by point ones on this one. Otherwise, you won't find the answer. So look, tell it to go to second window. Tell it to start at 0. And you're going to go by point 1. And go to second graph. And there's actually 2 answers for this one. Zach, what's one of the answers? When's it reach 20? At point 4. Anybody see the other answer? If you keep going when the ball comes back down, you don't have to put both of them, but it comes back down. It reaches 20 after 2.2. All right, try your OYOs.